Hello everyone. In this video we are looking at quad tree decomposition and how it can be used to plan paths. So basically what we want to achieve is that there's a robot and it's in an unknown space. It has a line of sight. So it starts moving in this space, finding what the path will be if we basically specify the start and the end point later. So it creates its own map, and that's what we want to achieve. So we have two codes over here. One is the quadtree.py, one is the robot.py. Robot.py is basically for the code where we create our robot and we tell it how to move, how the function runs using the Pygame console. And so basically all we do over here is tell the robot how to move, how to go about it, and give it different functions. Quadtree.py is the main code where we create the environment, and so we have the data set over here. So this is like used to create our space, and this one is in quadtree.py. What we do is we basically create the path using those points that we specified, and then we tell the robot how to perform quadtree decomposition using it. So let's quickly go over here and let me run this code. Okay, so it'll open up the Pygame console in maybe 10 seconds from now, and so what you will see is you'll actually see two windows. One window is basically so this is the one and this is the other one. Okay, so in this window we have an unknown path, unknown space in which our robot, which has this blue line of sight, so it starts moving from its start point and then it keeps on discovering the environment. So all the paths that come like in its way of sight, so it keeps on knowing them. And then over here what we create, it's actually planning its path, so it's plotting different points which it discovered. And so what will happen is, like, after the entire space has been searched, it has been through entire space, we can actually specify a start and an endpoint, and then this robot, using the uh, quadtree decomposition, like, it has already discovered what paths to take if specified a start and the endpoint. So using that, it will like find its path. So we'll have to wait till it like it explores the entire space. I think we're almost done now. Okay, so now that it has disappeared, it basically specifies, it tells us that it has actually searched the entire map, and so it says map size is 4 and so many zeros, and quad tree max size, quad tree size. Okay, so now what we can do is we can specify a start point and an end point, and it simply finds the path from the start to the end point. We can this so it says search time is 0.01, so that's quite good, and it visited 607 nodes, and it says it found the path. So what we can do is we can like take a trickier one, so this one, and let's say over here. Okay, so it goes over here and finds a path from this side. So if you decide to have a path that is actually not possible, so it will freeze for a second. Okay, so it freezes for a second and then it does nothing because we don't have a path, right? So I think this basically shows that the code is working fine. You can try one more. It will work every time. So visit 32. It has a high accuracy. If you have any queries, you can ask in the comment section. I'll be putting the link to the GitHub repository in the description. You can download the source code from there, and if you have any suggestions, you can suggest that to me in the comment section. So thanks for watching.